Alright, so this time around, we'll be trying to apply everything we learn in MIPS to solve a question. Right. So the question is simple. It says the following code fragment processes two arrays. Right. So you should take note that you'll be taking kind of two arrays and produces an important value in the register $v0. Right. So the $v0 is like our results register. Assume that each array contains 2,500 words, right? So take note, when you see a constant like 2,500 or something, you should know. Now, we start from 0 through to what? Um, word 2499, right? So, so that the base address of the array is stored in what? $A0 and $A1 respectively. Remember, they said two arrays, right? So it means we have two base addresses. And their size are stored in $A2 and what $A3 respectively. Now the main question is you are supposed to add comments to the code to show what this code specifically does. So that's the full question. And now they've given you some MIPS assembly code that you are supposed to analyze, right? So let's take our time and analyze it line by line. Now in the first line, you realize that they are taking the register A2, right, and they are doing something with it. But let's check what are they doing with it. And we realize that they said that the size of the array, right, is 2,500, and that size is stored in what A2 and A3. So it means that the arrays have both sizes and have equal sizes, right? They are both 2,500, and their sizes are being stored in A2 and A3. So it means that A2 stores 2,500, A3 stores 2,500. Now we realize that we are shifting left and we are storing the results in A2, right? And the source is A2 and it's by 2. So it means that shift A2 twice and store the results back in A2. So in this case, A2 will be containing 2500, but 2500 in binary is a long number. So let me take like, assume that A2 contained 1, right? So to contain something like 001. Now, after this instruction, it will come and contain like 100 because you shifted left twice, right? But what's the essence? Well, the truth is, it's very rational for this to be used as a stop condition when we are considering arrays. Why? Assuming you have an array, right? Remember, MIPS is byte addressable, but each each memory accesses a word, right? So you have an array, and let's assume that the array contains the elements 3, 4, 7, 2, right? Now let's say the base address is 0x00, right? Now, can you guess the address of the last element? Okay, so let's take our time. Now, if the base address is 0x00, right, and each of these one is supposed to occupy 4 bytes, right? 4 bytes, 4 bytes, 4 bytes. Then you realize that the starting address of this will be 0x00, and its ending address will be what? 0x03, right? So the ending address will be 0x03. But the starting address of this 4 would be what? 0x04, and its ending address will be what? 0x07. It will continue up towards the 2, whose starting address you can calculate as well, and the ending address you can calculate also. But if we are writing code, right, we cannot be memorizing these things one by one, right? So there's a short way, right? So you, for instance, the starting address of this 4 will be 0x04, right? So 0x04, let me just put 0x4, and its ending address will be 0x07. So the ending address will sound like 0x07. right? From 4 up to 7 is what? 4 bytes. Then the for the 7, the starting address was 0x08, and its ending address would be 0x what 11, right? So the ending address would be 0x what 11. Now for the 2, the starting address would be 0x 0x12, so 12. I'm not sure that that is 12 in hexadecimal. It will change, but let's assume that we are just doing binary, and its ending address is what 0x I think 15, right? It will end at 15, right? So the two will start getting stored at 12, and it will end at what um address what 15, right? So that's how it's going to be, right? However, you realize that there are one, two, three, four elements in this array, right? Now, since there are four elements in this array, at any point in time, when you are given the start address of the array, the base address of the array at 0x00, right? Now, if you add it to what 4 times the number of elements in the array, the number of the elements in the array is what 0x, and the number of elements in the array is 4, right? So 4 times the size of each byte is also 4. So 4 times 4 is what 16. Realize that when you add, you get 0x16 as your ending address. It means that your array spans from what 0x00 up to what 0x16. It means that the end of the array, that is at 0x16, we are beginning a new element, right? And now that's the necessity of multiplying by 4 here, or shifting left by 2. Shifting left by 2 is multiplying by 4. So these ones are just supposed to find the length, the end of array, right? So we are going to say find the end offset of array what 0 by multiplying size by what 4, right? And that's the same thing for the second part as well, right? Find the end offset of array 1 by multiplying the what and by multiplying the size by what 4. Yes. Now that's it. So for the first two lines, it's actually just to find the end of the array, and it is very crucial because we're using that very same thing in terminating conditions, right? We'll see that later. Now you realize that they said add into vin 0, 0 comma 0, right? And this is an add instruction, so they're adding 0 plus 0 and putting it into vin 0. But they told you that what the it produces an important value in register vin 0. So it means that our result is what in vin 0. So it means that we just can say or set result to 0. So set results to 0, right? So our beginning result is 0. And you also realize that we have another register add into t0, 0 comma 0. That is t0 is equal to 0 plus 0. Now you realize that they did not give you any register association for T0 here. So it's kind of hard to try and find it, right? So first, you just try to quickly go through the code if you can guess, right? So now when I look through the code, I realize that here they try adding T0 towards A0, and A0 is what? A0 is an address, right? So it means that T0 was acting as kind of an offset here. And here, yes, so I don't see T0 again until this part where they try to increase T0 by what? 4, right? Now I can see some branch equals, branch not equals. It means that there are some kind of, should I say, loops? Yes, maybe there will be loops, but and it seems like with this actuation, we are more or less increasing what T0 by what 4. These are guesswork. So I'm going to say that then let's call T0 something like the I part of the loop, right? So it means that it's either we can say we initialize T0 to be equal to 0, or set offset of array 0 towards 0. Now you also realize that T0 was being used here. I think this part. T0 was being used to be added to the base address and put into T4, which means that T0 is the offset, right? So if you are starting with, you can say we are setting the offset of array 0 to 0. We don't really know what it does, but maybe we may change it. So I think let me put this in red, right? I'm not really sure what it does at the moment. So then the next part is we have a label. Now, um, when you are starting your code and you've not hit any branch or something, right? And you have a label, or even if you hit a branch and you have a label as next, and the branch instruction does not execute, you just continue from the label, you just continue normally, like sequentially, right? So from this one, we come to the label and we continue, right? Now continuing, realize that they said add into T4, A0, T0, right? Now this is one part. So you realize that they are adding C0 to A0, and you are putting it into T4, right? So this is more like finding an address, right? An address of the next element. Remember, here the first element was located at 0x00. When you add 4, it was what the beginning of what the next element. So we can just make a quick comment. Find the address. You can here say find the address of the next element of array 0. Then once we do that, then we can come to the next, and the last line is load word into T4, $0 T4. So what are they doing? They are just fetching the element uh, at that address, right? Now someone may ask, but usually they should give an offset here, right? Which should be the number of element they should skip over to get it, to get the next element. Yes, it's true, but see, we have stored the base address in A0 and we have increased it by 4, right? So if you don't offset it, we'll still get the next element, right? This is just a bit of reverse, um, should I say, method of access, right? So it shouldn't be confusing. Then the last part is we've accessed the element, we stored it in C4. However, the next part is it says add into T1 0, and funny enough, you don't know what T1 is. But let's calm down. You realize that when you calm down, T1 is also used here. And now T1 is added to what? The base address of what? Array 1, right? And it's stored in T3, right? And let's see if we see T1 again. And we see that T1 is also increased by 4, right? So T1 is also like the um offsets which we are going to use, right? The offsets which we are going to use. So um more or less, we if this one was yes, so it means that we'll have to just use this comment. So if this one was kind of I, the T0 was I, then T1 will be something like G, right? Because I'm guessing it's some kind of outer loop and inner loop, right? So we can just copy and paste that one there. So initialize T1 to 0, or set the offset of array 1 towards 0, right? That's what we are doing. Now, when we come to the next line, realize that we are loading, right? And we are loading by what? We are loading by the new address we've evaluated in T3, and we are storing the results in T3. So this is also like fetching the ith or the jth element in this case of what? Array 1, right? So we can just type it like fetch the element at the address specified in T3, right? I know maybe my comments may not be very descriptive, so we'll need to come over it again, but for now, let's make use of this. Then the next one is, it says branch not equal. Branch not equal, you realize that we are comparing T3 and T4. Now, we don't know what is in T3 and T4, so let's go back. Remember that here, what was T4? T4 was this one. Remember that we fetch the element in the first array, right, and put it into T4. And here, realize that we also fetch the element in the second array and put it into T3. So it's like the two arrays, we have fetched their elements from both of them. And now we are coming to compare them kind of with the branch not equal. So we are saying that compare them. If they are not equal, come towards skip, right? That's the branch not equal. Now when you come to skip, the offset for, I think, the inner array, right? The offset for the array 1 is increased by 4, right? And now if you realize that the offset is not at the end of the array, we go back to what's inner, right? So this is what causes the loop. And yes, we've realized it. So from here, we check if the element we fetch from the second array is not equal to the element we fetch from the first array, then we try to evaluate the next offset of the second array. Then we branch if the offset we've evaluated is not the end of the second array, so that we can use it to access the next element of the second array, right? It's a bit confusing because it's a whole lot of assembly, but we'll see a sample free code and it will be fine. So that's what we are doing. So it's like a nested loop. You realize that this inner will run until like it will run these two lines, one, two lines. They will run and even three, right? They will run until you hit either you hit either you hit a condition where the offset is at the end of the array. Now that condition will be what, 4 times 2400, right? Where T1 has become 4 times 2400, because remember we multiply by 4 because they contain 2500 words, right? And we are increasing by 4 4 4 4 4 continuously. So that's what you see. Now the so that's what you see. So this is just like an if statement. So check if, so let me bring it down. So check if both elements of the arrays compare, right? So this is the if statement. Right now, if don't compare, sorry. So if they don't compare, then execute. So this is the start of the if statement, right? And now this is actually the else statement. The one just below is the else statement. So else statement, right? Right. So the one below is the else statement. So the add I v 0 to v1 is the else statement. At the start of the if statement stands from the skip, right? So you just check if the elements you pick from the two arrays are equal. If they are not equal, then you are if you check if they are not equal, that's the branch not equal to. They are not equal, you come to skip, right? And you continue to execute from skip. If they are equal, then you increment the value in the result by 1, right? Now here you can also state the if condition in another way, but let's not worry about that. So you realize that the next part is that if they are not equal, right, then you evaluate the next offset. So that's what the next you evaluate the next offset for. array 0, array 1, sorry, that's the inner array. Then you check if you are not at the end of the array, right? So that's for the one just below it. And now if you check if you are not at the end of the array, then you go back to fetch and compare again. However, if you are at the end of the array, then you would evaluate the next offset for array 0. Because why? Because remember, array 0 was referring to a 30 was used for the offset for what? Array 0. That's what you can see here, right? So evaluate the next offset for array 0. And now check that array 0 has not also what reached the end. We check if array 0 has not reached the end, right? So it's not very complicated as it seems, right? It's just a bunch of very small instructions which are being joined together to do a very seemingly complex task. However, what I would like you to appreciate is that there are kind of loops in this instruction, right? And based on the how it is being executed, you realize that some parts will run the inner one will run multiple times before the outer one will be called once, right? So this is like a nested for loop, right? Now to appreciate it more, I sampled it a C code, right? So this is like what you see up there, right? Now let's see. So the code you see up there is made up of two array, and I call it A0 and A1 here in this case. Now the return value I initialize it with 0, and that's what when 0 is equal to 0 0, right? Then I say for int I is equal to 0, I is less than size of a I plus plus. Now that I, right, this is C, right? But that I for the outer loop is what was represented here as what? As T0, right? And now for in J is equal to 0, J is less than size, J plus plus what? That J is what was represented here as the inner loop. The smaller, I think that one was called a T1, right? Now you realize that I'm checking for what? Where I is equal to J, right? That is the element in the smaller array is equal to the element in the inner array is equal to the element in the what outer array. If they are both equal, then I increase the return value with 1, right? And that's what you see here. Increase the return value with 1, right? Now, if you've done a little bit of programming, you realize that this code is more or less equivalent to this code, right? Now, what this code does, and that's the next part of the question, it says specifically what would be returned this and add comments to the code and describe in one sentence what this code does. So this code will just what return the number of what equivalent elements in the two arrays, right? And specifically what will be returned, yes. So this code compares two arrays, right? And counts the number of what elements which are equal in both arrays, right? So what will be returned is just the number of equal elements in both arrays. Hope that makes it clear for you. So yeah, hope that makes it clear for you. And even though we've not uh, really specialized our comments, I hope you try to make your comments more descriptive as possible, and that will go a long way to help you in understanding this question.